Hello everyone, myself Suresh Rajviswal, and in this video we would be seeing how to set up firewall policies using ASA in GNS3. So before getting started, the first word as we can see is firewall. So what exactly is a firewall?
So firewall is a network security system or shielding layer. Okay, it's a system or a sort of layer we can tell that lies between, like generally lies between the internet and the computer networks. It typically sets a barrier between the trusted network and an untrusted network to protect the trusted network from the malicious internet traffic. Okay, think of it like we have our own house. Okay, so our house is protected by some sort of wall or some sort of a gate. So you can tell that to be a firewall. Suppose we take the example of our NIT University. So we have a main gate, right? So that can be sort of a firewall because that protects the entire university, the entire campus, and the people residing inside the campus from the outsiders, from the elements of the outside world. It does not restrict the elements of the outside world completely. No, it doesn't do that. But it is sort of a filter. It like checks people go there, people verify their identity, and only then can they enter inside the campus. Similarly, it does not it monitors the traffic that is going into the system and going out of the system. So basically, firewall is sort of a barrier between two networks, generally a trusted and an untrusted network. And the main purpose of a firewall is to control the incoming and outgoing traffic so as to prevent any malicious things, or any malicious activities, or any malicious attacker to enter into a system. Okay. So firewalls primarily, like the focus is to carefully analyze the income traffic. Okay, the traffic which is coming from the outside to the inside, the incoming traffic, they primarily analyze that based on some pre-established rules and filter the traffic coming from unsecured or suspicious sources to prevent the attacks. Okay, fair enough. Firewall guard traffic at a computer's entry point called ports, which is where information is exchanged with external devices. Right? So we know that whenever we take any service, say HTTP, HTTPS, Telnet, SMTP, FTP, any service we do, any thing we run on a computer, it is basically happening via a port. And this port is the entry point for every service to run. It has to run via some port. So what a firewall does is that it establishes itself on these ports, we can tell, and it filters the traffic and it prevents any malicious traffic from entering into a system. That is the primary objective of a firewall. Okay, moving on to the next slide. What is the importance of a hardware firewall? Okay, now see, we understood what a firewall is, and it is obvious also that firewall can be both hardware based as well as software based. Now, when I say software based, it means that it is generally something which we have on our own systems. It is something which can be deployed very easily on individual systems. But when we have large organizations, say NIT University or say Infosys or say any large organization that have a plethora of devices connected within the internal network, within their internal LAN. So in those cases, there is also a hardware firewall, which is a basically dedicated device for this filtering and all these things placed so that things can be much more practically handled in a much more better way. So hardware firewall is a dedicated physical device, or it can also be a set of physical devices which act as the first line of defense for a computer network by filtering out traffic from unauthorized users. So this basically means to say that okay, it's fine, absolutely fine if you want to have a firewall installed on your system, on your personal laptop, or on your end devices as well. That's absolutely fine. But as a first line of defense for all the devices within a particular area, so this hardware firewall acts like a main gate wherein it just blocks all the unauthorized traffic. It is the first line of defense, we can tell, right? They are specifically designed hardware for performing data packet filtering. Now think of this, or to understand this better, we can think like this is a device that is made for this purpose. Our end devices like my laptop or any laptop which is being used by some other person, they are not primarily designed to function as a firewall. Okay, they can function as a firewall, they can have the firewall services running on it, that's absolutely fine, but they are not specifically designed for it. But when we have a device which is specifically designed for something, what are the advantages that we can get? Definitely there will be multiple advantages, like we can get a much faster response, we can filter a lot of packets simultaneously and so on, and that is what we are going to see forward also, like in the forthcoming slides as well. So here it is mentioned that as they are dedicatedly used, okay, for a specific purpose, okay, as they're dedicatedly used for a specific purpose, they can protect a range of devices on the network with reduced latency and higher throughput. That is, the latency, the time taken for processing is very less, and the number of packets being processed per second is very high. So the latency reduces, which is a great advantage, and also the throughput increases simultaneously. And this also allows setting up a very specific firewall rules as per the company's requirements. Okay, think of it like we can tell that, okay, I have 1000 devices on my network. So which is a better option where to configure each and every single device for all the specific rules and policies which I want to implement in my organization? Will that be a better option? Or having a first line of defense wherein everything is there in just one device and all the devices are then segregated from that or connected through that, we can tell. So which one is better? Definitely if we have one device wherein we can customize everything, a dedicated device wherein we can customize everything, that is definitely a very better solution for many organizations. Okay, and not just with this firewalls, they not only provide this data filtering capabilities, there are also other functionalities expected from them as well, which they definitely provide, like VPN routing, etc. Okay, so now till now we saw some really good advantages of using a hardware firewall, but as a dedicated device which are used mainly in large organizations, the thing to remember is that they are very costly, and this cost increases proportionally with the need for increased protection. Also, they require additional space and resources as expected, and they also require skilled manpower for setting up and maintenance, because it is not a very easy task to do, and it is not a very straightforward thing to do. We need to the people who would be like into setting up and maintenance of these hardware firewalls, they need to be specifically trained, and the resources need to be invested according to the requirements of the company. So it is not just like, okay, I have an organization and I want a good line of protection, so I'll just go ahead and get a hardware firewall without without having anything to worry. No, it is not like that. We need to ensure that the people are properly trained and the network is properly configured, so that we can judge the benefits we are getting out of a hardware firewall and so on. So for that, for ensuring that these things happen before getting the actual device on board, we can do some sort of a simulation wherein we can like ensure that, okay, this is the firewall which I'm going to purchase. So I'll try to have a system wherein I can simulate the same thing on virtually on a virtual environment. And this is where GNS3 comes into picture, because GNS3, or Graphical Network Simulator 3, is a network software emulator that allows the combination of virtual and real devices used to simulate complex networks. Okay, because it's pretty obvious that when you have an organization, the network architecture is never going to be a one-shot simple solution. It is definitely going to be a network of networks, and it will be a very complex thing. And to simulate that and to see the benefits of using a hardware firewall, we need a good simulation tool. And GNS3 is a very widely and popularly used tool for this. Okay, it helps build, design, and test. Okay, three things: build the network, design the architecture and all the things, and finally test the network in a risk-free virtual environment. Okay, ASA stands for Adaptive Security Appliance. So till now we understood what GNS3 is. We understood it. Okay, it's a tool. Now, what about the firewall? The firewall which I'll be purchasing. Generally, the hardware firewall, the most widely used one is that of Cisco ASA. Cisco ASA is most widely used. And when I say Cisco ASA, the ASA part stands for Adaptive Security Appliance. It's just not a firewall; it's a security appliance, we can tell. It is the fundamental operating system for the Cisco ASA family of products. It provides enterprise-level firewall ability for the ASA devices. Okay, so these ASA devices, these adaptive security appliances, run on this ASA software, which we would be simulating with the help of this GNS3 platform. Okay, so GNS3 supports the Cisco ASA that can be used to perform hands-on practice and understand the hardware firewall in a much more better and efficient way. Okay, so Cisco ASA is a security device. This is how the device actually looks like, and the cost is in multitude of lakhs. So it's a very costly device which can be heavily customized. And in GNS3, which is a free platform, we can do the simulation very easily. There are just a few things to learn, which we will be seeing in this video log, and we will be seeing how do we actually use the Cisco ASA practically on a corporate network, wherein you have the external or the untrusted network, you have the internal network, and you also even have a DMZ. Okay, we're also taking a DMZ so that it's sort of a middleware, sort of a middle network that can filter the traffic in between, or how can this device by default, even if we just install the device with just minimum settings and just minimum setup of the routing protocols and all, even then we can see how this Cisco ASA device, okay, can help filter malicious packets from entering into the system. Okay, so Cisco ASA is a security device that combines firewall, antivirus, intrusion prevention, and VPN capabilities. Okay, as I said, it is a security appliance. It is not just a firewall device. Okay, it's a security device that combines firewall, antivirus, intrusion prevention, and VPN capabilities. It provides proactive threat defense that stops attack before they spread through the network. An ASA is valuable and flexible in that it can be used as a security solution for both small and large networks. As I said, it can be heavily customized, based on the requirements. Okay, And how are these customizations done, or how is this access controlled in an ASA? It is definitely with the use of ACL, access control list. Okay, so it is not like, definitely there has to be an access control list using which we can tell that, okay, this is what should be allowed to enter and this is what should not be allowed to enter. Okay, so an access control list is one of the main feature of Cisco Adaptive Security Appliance ASA that helps in filtering the traffic flow across the connected interfaces of Cisco ASA firewall appliance and prevents a certain traffic from entering or exiting from a network. So this was something about the importance of hardware firewall, the role of hardware firewall in modern organizations, and how using GNS3 platform and this ASA simulate software we can simulate that. So let's understand a bit more about ACL on ASA. After that, or I think let's have some demo on whatever we saw till now. And once we are done with setting up of our corporate network and installation of ASA, and when it comes to actually filtering of the traffic and establishing the rules, that time we can go ahead and understand ASL or ACL on this ASA in a much more detailed way. So for this, we would be using a GNS3 software, which I've already installed in the system. This is the GNS3 software. Now, one thing to remember over here, the key thing to remember over here is that it is a resource intensive software, and we need to be very patient while using this software, because one, we can tell sort of hurriness can result in the entire system getting stuck in the middle, and we don't want to lose all our safe work or all our hard-earned work. So we need to be a bit careful while using this. So let us name our project as ANS2 underscore MT20SCS 525 vlog1. Okay. Click on OK. So the first thing that we need to do is we need to go to this edit and preferences. Now, as I said, this is a simulation software. GNS3 is a simulation software. So we need to actually add the devices which we would be using on our real network. So what are the devices that we need for a basic simulation to be done? We need routers and we need this ASA firewall. These are the two basic things which we need. So when we come from router, we can see we have iOS routers. Now what I have done is that I have already added a few routers over here, as we can see. So if I expand this further, we can see the details. So this is a router C2600. So how do you add a router? We basically need to download an image of that router. Okay, and once we download the image of that router, we need to specify the RAM and all those physical things, the network number of slots and the RAM and those things. We can click on it and see that. So this is the name, this is the platform. Okay, we have to give two things over here, the iOS image path. So this is easily available online. We can download this image file online and we can give this, then we can set up the memory we want. Over here I have taken 160 MB RAM because it is sufficient, and I've given one slot because we just need this for demo purpose, and we can have as many number of slots we want based on our requirements. So to add a new one, we can just click on new, we can just upload the iOS image file. Okay, I have like these are the four things which I've uploaded. So let's take a random one for example, and then we can just give the default ones, and because this name is already in use, so we can just go ahead and add this router if required. So basically we would be using the C2600 router for a demo purpose. Okay, and this is the path from which it has been loaded actually. We also need the ASA device. So where to do that? We need to go to this QENUVM. Over here we need to add the ASA device. Same thing here also, we need to download two files from the net. One is the IM3, the initialization file we can tell, and other is this kernel file for this VM-liners file. So once we get these two initial RAM disk and kernel image files from the internet, we just need to load these two location of these two files. We need to give some commands over here, the generic commands as to the default settings we can tell. Okay, easily available online, the default options. And we also need to, yes, another extra thing over here is that in this step we also need to provide an hard disk for this ASA to work. Okay, because this is a dedicated device that can perform multiple things, it also needs a hard disk. So we need to also assign some hard disk to it. Okay, and a memory RAM as well. So I've assigned 1 GB RAM over here, and I've also assigned around 512 MB of flash memory to this ASA device. We can see the properties over here. Okay, this is the name, RAM size, and this is the default QEMU hard disk. Okay, we can see over here that I've created this flash memory, and steps are easily available online, but this is not the crux of what I'm going to discuss. So I'm skipping this part on how to add a flash memory. And we have given 4 NIC adapters to it because we would be requiring basically 3, but for one extra given for emergency. So we would be having 4 adapters, and we need these two files. Okay, the IM3 IP and the kernel image available online. So over here we can see that I had kept this. I have also kept ASA 842 and ASA 915. Over here I will be using ASA 915. You can see ASA 915 is being used. So 91521, these two files. Okay, once we have it, we can just load that. We can give this default commands and options and click on OK, and our ASA would be ready to use. Okay, fair enough till now. So after doing these things, Next thing is setting up or creating our virtual environment or the virtual architecture. So how do we do that? I'll click on this. All the devices that are available in this platform are now over here. The first thing is ASA. Now, before starting with anything, the thing to note is that ASA, if you get it by default, okay, most of the services are disabled. Okay, so to enable them, we need to purchase a license, and this thing is such that for every service you need to have a license. So based on the requirements, when we said the cost increases proportionally, so yes, based on the requirements, we have to purchase a license for a physical ASA device. Over here, if we just right click and click on console, nothing would come. Why? Because it is showing as red. It is not yet started. So first I would need to start. So right click and click on start. And if I have multiple devices, I can click on the start or resume all devices. I'll right click on console. Over here, we need to wait for some seconds because if we get impatient, it might just not work. Okay. So yeah, now we are seeing that okay, something is being loaded. What we can do is we can go over here, change settings, appearance, change the font to set to for better visibility. This will take some time, and there is no option to fast forward that. We have to be patient with this. Initially, our primary objective now is to see which services are disabled, and because we need some services, so what we can do is we can get an activation key online using the serial number. For now, for this virtual platform, we have a constant serial number 12129 and then 80. So if we get the serial number, we can get activation keys. So there are multiple activation keys, and I've chosen a very basic one because if we get an activation key for more number of services, definitely it will take more time to load each time like we start our system. So that's not required for us. So that's why over here we can see all services almost disabled. So we would give now an activation key that would enable the minimum number of services that is required for our purpose, or that is required for a general ASA to like function properly. Okay. So yes, let the power on self test complete, and this is the activation key that I had found. Okay. So we can just copy this one over here, and we have to wait for this one to complete. Power on self test is in progress. It will take some time. We need to wait for a bit. Here we were able to get this. I do not want to pre-configure firewall, and now we can see that yes, this system has been loaded completely after all these zeros and all. So now, if I go to enable, we need to give a password, and I will give conf. Okay, I just give a command show version. Now what we can see is almost all the services are currently disabled. So what do I need to do? I need to give an activation key. So I'll copy this activation key once again. I'll keep that. I'll enter this activation key. It will say update flash activation key. I would give by yes. And it will tell me that the flash permanent activation key was updated with requested key, and it will become active after next reload. So what do I need to do? I need to reload my ASA. So I'll close this. I'll right click this one, click on stop. Again right click on start. Wait for this to turn green, then go to console and patiently wait for the command prompt, like the things to fire up. Yes, it is coming. So I'll again go to change settings, appearance. This step it's not necessary, but I'm doing it just for better visibility, and it needs to be done every time. So by the time the system goes, we can do this. So over here again, we need to patiently wait till the things get loaded properly. We can see that okay, the things have loaded again, and we do not have to pre-configure anything. I'll click on no. I will expand this. I'll again go to enable, need to enter the password and show version. So now what we can see is that these two services have been enabled, and failover is also now present inside host. Something we needed is also now unlimited, and so we can see that basically the activation key has shown its purpose, and some services have been enabled. So this is how we used to set up an activation key, and now we can also see that okay, this is the activation key that is currently running on our system, and this is the serial number. Now one thing which can help practically enhance the speed a lot of ASA is that if we go to over here, we can see that this is running through EMU, and this ASA device runs inside QEMU. We have seen that initially. So if I go to the details over here, and I right click and click on set definitive, what I can do is my system has 4 processor cores, so I can assign one core dedicatedly for uh, our queue of this ASA. So I will give it CPU 3, so that because generally the processors use the first core or the first and second core. So what I can do is I can just give it the third core so that it doesn't make other systems slow. So that can actually help speed up the system a lot. So now my ASA is actually loaded, or the ASA is basically set up. Okay. So now what I need to do, I need to set up my environment, architecture. How would my network look like? So we can do one thing. We can take a switch. Okay. I'll take a switch over here. I'll take another switch over here. Okay, and I'll take a basic router. I'll put a router over here. I'll put, okay, we need to wait. I'll put another router over here, and I will put another router over here. Okay, fair enough. Now what is my requirement? What do I primarily want to do? Let's see that. Just bring this a bit down. Okay, so this is the central ASA device. I will have this portion, okay, as the internal network, and this portion, as we can say, the external network. Okay, so that is what my requirement is now. And how do I do that? So I'll just take the wire, connect the wire. So this one, switch 1, I will connect it to Ethernet 1. Why? Because this 1 looks like I. So Ethernet. So we can, like, for easier understanding, we can just connect it with Ethernet 1. It cannot be added. Why? Because ASA is running. So first I need to stop the ASA. I click on, right click, and stop the ASA for now. Okay. And when I will be stopping, I need to close this one. I need to close the console. So now I click on this one and I will connect it to internet network. Okay. Then what I would do, this O, this resembles like outside. So O. So I connect from here to this one. Switch 2. Done? Fair enough. So these were the 2 switches. We can also directly use routers, but I'm not using routers directly on the ASA because in case we want to have multiple systems, it will be easier to connect them via the switch than a router directly. Okay, and we have also given only one port for a router, so I'm basically using a switch over. So the next portion is connecting this switch to the router 1, 0 by 0. This one also we can connect over here, and this one also Ethernet 2 to this one. Okay, so these 3 basic connections we have done till now. And if you want to see the ports, we can just click on go to view, and we can click on show or hide interface labels. Okay, so what do we see till now? That okay, now one thing to know is that this is showing as E. E is for Ethernet, but these are actually gigabit Ethernet. So if we were not confused, just to avoid any confusion, we can just replace them with G, so that we can be sure that these are gigabit Ethernet devices and not plain Ethernet devices. Okay, and this one is also not E. This is actually okay. Yeah, this one is the router will be Ethernet only. This is C2600, so this will be Ethernet. Okay, 0 by 0. No issues on this part. So now I need to assign IP addresses. So how do I do that? So let me just write what I'm going to assign first. So my primary objective is on this ASA, I need to assign 3 IP addresses first. So for 3 different networks, because this is internal network, this is external network, and this is going to be the DMZ network. So what I would give this port, I would give 10.0.0.10. This one I would give to say G1, and over here I can give 20.0.0.10. I'm intentionally giving .10 so that out like on the last part of this network ID, so this IP address, so that it will be easier for me to remember. And over here I can give 30.0.0.10. Okay, so 3 different networks on 3 different ports of the ASA. Fair enough. So now for this is, as this one we can see is 10.0.0.10. Okay, so this network would be the 10.0.0 network. Okay, this is the internal network. This one would be the internal network. This one would be the outside. Let me give it the name inside and outside network for better correlation later. I'll let you know why I'm using this names. I'll give this inside network, outside network, and this one I will give as DMZ network. Okay, fair enough. Okay, now we also need to give IP addresses for which one? This part. Okay, so what IP address can I give for this router? I can give over here 10.0.0.1 because this is of the same network. I can give over here 20.0.0.2, fair enough, and I can give here 30.0.0.3. Okay, so For the 3 routers, we have 3 addresses that we are going to assign to them. We are going to now start our coding work. And over here for the ASA, we have 10, 20, and 30. So this is how the basic architecture is going to look like. We can just save this one. And now comes the starting, how to start this. So first I will start the ASA. Okay. So I'll click on start. I'll wait for the 3 links to go green. Over here also I can see the link is going glowing green. So now I go to console. So we'll wait patiently for the console to load up, because one click, while this is not yet loaded, it can crash the entire system down. So change settings, appearance. I just increase the font size so that we can view easily. You can ignore these warnings. It's absolutely fine, nothing to worry about. Because even though we are trying to emulate as much closely as possible a physical network, but still it's a virtual network, so yeah, some things can be ignored. So yes, we had given 4 Ethernet cards for an IC, so yes, they are loading up. ASA will take some time to start, as expected. Let's wait for that. Now this thing has loaded, and now we can see that do we need to pre-configure the firewall? No pre-configuration. So click on no. Okay, now what we can see that no restore enable, no need of entering password, and I click on show version. I'll just make this full screen. So now we can see that yes, everything has been saved, no issues till now. The activation key is active, whichever we had given, and now the time comes to assign the IP addresses that we had given on this network over here to practically need to assign them. So first is the internal network G1. G1 needs to be assigned the IP address 10.0.0.10. So how do I do that? I'll go to interface. Not like it. I'll go to conf t. Okay, I do not want any anonymous reporting for now. I'll go to interface, the Ethernet 1. Okay, and the IP address that I will need to add over here is IP address should be 10.0.0.10. Now, in a router, we also need to give the subnet mask, but over here, because we are using the default classful networking, we are not going for the CIDR, so no need to give any subnet mask or any CIDR. We can just give this IP address. We'll take the default one, and we can also verify that. And now I can also give no shutdown. Okay, and I'll click on exit. Now let's see if this is actually saved. So how can we see that whether this command is actually saved or not? We can give show interface IP brief. Okay, slightly different from the normal, what we can say, normal router ones which we traditionally use in the packet tracer, but yes, this is how it looks over here. Okay, so here we can see that we had given 2 commands. One was that we had added the IP address, and we had given the no shut command for gigabit connect 1. So we can see that this no shut command is working, the status is up, but the IP address is not working. So why is this so? This is so because in ASA we also need to give mandatorily a name. Until and unless we do not give a name, this is not going to get saved. Actually, our command has been executed. If I just give the command show running config, we can see that okay, my command is executed. The IP address is over here, but it will not reflect while like running, because we have not assigned a name. And in ASA, the moment we assign a name, it will also assign a security level to it. Okay, so we need to give 2 more things, not just the IP address and the no shut command. We also need to give the name and the security level, and this security level will act as a default ACL, we can say, or it will help like set up a default access that because a higher security level can access or can send packets to a lower security level, to a network at the lower security level. But a network at a lower security level, at a lower security interface level, cannot send packets or cannot communicate directly to a network at a higher security level. So along with the name, we have to also give them security levels as well. So we will see that. How do we do that? Okay, I'll just clear these things. Okay, fair enough. So I have to again interface G1. Okay, and I have given the IP address and no shut command. Now I have to also give the name. If is the command, plus and the name, I will give the name inside. This is why I give the name inside. Why? Because the moment I click enter, it will set the security level for inside as 100. This is a default. If I spell like give us any other spelling of inside, or if I give any other words, this security level will be set to 0 by default. Only for INSIBE, no matter whatever is the caps, it will be 100 by default. So security is 100, means it's the most secure network we can tell. Okay, so this is the name given. I do not need to configure the security level for this. I can just exit. Okay, now I need to interface with G2. or G0. Okay, let's interface with G0 over here, the outside network. Fair enough. I'll interface with G0. I'll give the IP address as, what is the IP address on this part? 20.0.0.10. 20.0.0.10. Do we need to give the subnet mask or anything like that? Absolutely no. Okay, no shut. And we also need to give which command along with that? The name is outside. And we can see the security level has been set to 0. Do we want 0? Yes, let it be 0. Who cares? No issues at all. So no need of changing the security level over here. And then exit. Now we also need to set up this DMZ. We have told that we will having three networks. So for the DMZ network, I will be interfacing with G2. So interface with Ethernet 2. Okay, and IP space address will be ending with 30. Sorry for the space, 30.0.0.10. Okay, enter. And what I have to also give no shut, and I have to also give the command of name if DMZ. Okay, now for this one, the security level is 0. I'll just write over here outside network security level equals to 0. Fair enough, no issues. Inside network security level was 100. Okay, fair enough. Now for DMZ, I cannot have 0 because if I give it 0, that would be, it would make no sense. So I have to give some intermediate value. Let's have it as 50. We can give any value we want. Okay, so we'll give it 50. So the command is security level is 50. Okay, this is one additional command which I have given for DMZ. Now I will click on exit. And again go to exit. Okay, now if I give the command show interface IP brief. Okay, now we can see that yes, the IP addresses are shown over here, 20, 10, and 30, and all these three are up. Status is up. You have a Ethernet for outside, inside, and DMZ. And there is another beautiful command, show name. If we give this command, we can see the security levels that have been assigned for these different zones. Okay, so for the inside zone, the security level is 100. For the outside zone, the security level is 0, and for DMZ, it's 50. I hope it's clear enough till now. Okay, so this is what we have done till now on the ASA part. And I think this is enough for now for the ASA. For the ASA setup, we have basically assigned the IP addresses. That is what were for the different ports, and these different ports act as now interfaces. So the security level is also set, so we can close this one for now. Now we need to go to the individual router. So I click on this, I'll click on start. Okay, let's go to the console. It's working. And as I have said earlier, we need to be very patient while using these things, because one click at the wrong time can crash the entire system down. Yeah. Yes, so the router is loaded up. One thing which I want to do now, I forgot that, sorry. On the Cisco ASA console, I would give write to memory. So whatever I have given is saved to the memory. I will not lose it. Close that. Now let's go to this router. So on the router, what do we need to do? Like, it's pretty obvious thing. We have this port 10.0.0.1 running on Ethernet 0. So we need to assign this IP address to this Ethernet 0. And because we are having this multiple networks, okay, so we also need to set up a routing protocol, right? Because otherwise we cannot communicate. From logically also, suppose even if I did not have any firewall and I have multiple routers on my network. So how do I communicate from one router to the other router? I need to have some routing protocol as well, right? So let's use OSPF for that. We can use any routing protocol, but for this demonstration purpose, I'm using OSPF. So over here, I'll go to enable mode. Sorry, it's not enable mode. I'll go to the config mode. Okay, I will go interface Ethernet 0/0. First thing, no shut. Okay, next thing, IP address. What is the IP address? 10.0.0.1 we have given, and over here, yes, we need to give this to 55.0.0.0. Why? Because it's a class, and it's not the ASA. Had it been ASA, we would have skipped this thing. Okay, so IP address given, exit. Now what I also want to do is I can also have a loopback address, not necessary, but it's for the demonstration of ACL in a later way. Let's have a loopback address as well. So int loopback 0. We'll give the address IP address 1.1.1.1. Let's have this one 255.255.255.255. Okay, for the loopback purpose only. Enter, and then just exit. Then two IP addresses set. Now what we need to do, we need to configure the routing protocol on this particular router. So how do I do that? I will go router OSPF, let's give a name, say let's give OSPF 1. Okay, what is the network ID that I want as a part of area 0? Okay, so that I can give two networks under 10.0.0.0 and yeah, 10 dot space wildcard mask 0.255.255.255 space area 0. Okay, and network 1.1.1.1 space wildcard 0.0.0.0 space area space 0. Enter. Fair enough. Exit and commit to memory. Yes. Then everything configured on this router and saved. Okay. Now let's go to router number 2. I click on start. Wait for a few seconds, then go to console. It's starting up. In the meanwhile, change settings, appearance. Okay. Starting. Done. So enable mode on configuration mode. Okay, interface 0 by 0. So interface Ethernet 0 by 0. No shut, make it on. Give the IP address as 20.0.0.2. Okay, that is the IP address we have given over here. 255.0.0.0. Enter. Exit. Interface loopback 0. IP address 2.2.2.2. Let's keep that 2.2.2.2. Space 255.255.255.255. Enter. Exit. Okay, IP address set, loopback address set. Now we have to configure the OSPF routing protocol. So router OSPF 1. Okay, network 20.0.0.0 space 0.255.255.255. The Wi-Fi mask is now in area 0. Network 2.2.2.2 then 0.0.0.0 yeah 0 is also in area 0. Okay, now exit memory. Yes. So then router 2 is also up and running. We'll close this one. Go to router 3. Click on start. Right click, click on console. Right click over here, change settings, appearance, change the font to 40. Then so now we are into router 3. Over here we have to give the IP address 30.0.0.3. Okay, so I'll just expand this mode. Interface Ethernet 0 by 0. Okay, now I have to give no shut. First command is no shut, then I have to give the IP address. With the IP address 30.0.0.3. Okay, fair enough. 255.0.0.0. Okay, exit. Then loopback interface loopback 0. IP address, let's give it as 3.3.3.3. Is 255.255.255.255. Enter and exit. Done. So now the IP address is added 30.0.0.3. The loopback address is added 3.3.3.3. Next, configuring the router protocol, OSPF protocol router, OSPF 1. What are the networks? Network will be 30.0.0.0 space wildcard mask 0.255.255.255. This will be in area 0. Okay, and again network 3.3.3.3 in 0.0.0.0 in area 0. Okay, done. And also we can give directly no issues, and we can give write to memory. Yes, write the default settings. Okay, so with this router 3 is also set up. Okay, fair enough. Now OSPF protocol has been set up on the 3 routers. IP addresses have been assigned on the ASA device as well, but we also need to set up the OSPF protocol on the ASA, because otherwise it won't. This is the intermediate device that everything has to pass through. So we also need to set up this OSPF on this ASA as well. So again, we would right click over here and click on console and just make the font a bit bigger. 14 is fair enough. Okay, so how do I configure that? I will go to conf t router. Why is it not happening? Okay, router OSPF1, the same name. Whatever the three networks we had given on this network, 10.0.0.0 and 255. Over here, you have to give the subnet mask, not the wildcard entry. Okay, 0.0.0, and this was in area 0. Okay. Again, network was 20.0.0.0 space 255.0.0.0, also on area 0. Okay. Again, we had network 30.0.0.0 on area 0. Okay, fair enough. Done. Exit. Right. Memory. Yes. Now what we can do, we can give the command show OSPF root. Okay, sorry. Show OSPF, show root and show OSPF neighbor. So we can see the OSPF neighbors over here. So we can see that based on this loopback addresses we had given, 1.1.1.1 was for this one, R1. So we had given over here, this one was 1.1.1.1. This was given, R2 was given 2.2.2.2, and DMZ was given 3.3.3.3. Okay, so we can see that 1.1.1.1 is on the inside network, on the inside interface. This is the keyword over here, inside interface, with connected with which through which router, like 10.0.0.1 IP address. Okay, this port. Okay, and then 2.2.2.2, this one connected by this port 20.0.0.2 on the outside interface, and this one on the DMZ interface we have 30.0.0.3 connected. Okay, so this is working. The OSPF neighbors are set up fairly in show root. If we see the root as well, we can see that C is for connected and O is for OSPF. So connected roots, we can see 10, 20, and 30 are connected by these interfaces. 10 is connected by inside, I resembles 1, so 10 resembles inside, and 20, as we had said, this one resembles like this is for the outside, and 30 is for the DMZ. Okay, and via the OSPF, we can also see that these networks are also connected. These loopback addresses, as we are saying, okay, these routers are connected via these interfaces. This is the these zones. Okay, we can just, this is now what now, because we know that there are security levels associated with these zones. If I give the command show name, if we can see that for these names, for these zones, we have security levels, and based on the security levels, by default, even if you do not configure any particular, any specific access list as well, even then by default we can see some particular things on this. Okay, so let's do one thing. Let's have a small demo for that. So we can do one thing. We can have the telnet service. We can see whether we're able to telnet from one router to another router, and based on the different zones. So I just minimize this, but I think I have not set up the telnet service. So I have to go to the router and we have to set up the telnet service. So enable conf t line vty0 space 4. Password is 123. Okay, and login. Enable password also we will do 123. Exit and write to memory. Okay, the telnet service has been configured on router 1 by just saving this to memory. It's saved. Again, configure the same on router 2. We go to enable mode, terminal mode, line vty0 space 4. Pass is 123 and login. We'll also give the enable password as 123. Exit and write to memory. Okay, we're configuring the telnet services now. Okay, R2 done. Let's minimize this. R3, let's open the console. Enable conf line vty0 is 4, password is 1, 2, 3. Okay, and after this we can just give login and enable password will be also 1, 2, 3 and exit and write to memory. Okay, so now what we have done is we have configured telnet services on all three routers on all three interfaces. Okay, on interfaces with security level is 100, interfaces with security level 0, and interface with security level is 50. Okay, so now if we go to ASA's console, let's see if the ASA console is open. Yeah. Okay, if I give a very basic command over here, show running config, what we can see over here is, okay, everything is we are seeing over here. Yes, so we can see that there are some policies which are inspected by default. Telnet is not listed over here, but it is also a part of this listed services, and because these services are inspected by default, so even if we do not configure them specifically, still they would be inspected based on the security levels, and accordingly they would be allowed to enter into the system or go out of the system. So that is what we are going to demo over here right now. So we will just minimize this ASA. Router 1, we will open the console. I'll just expand this a bit so that it's easier. Okay. So now what I will do, now I want to telnet from router 1 to say router 2, from a security level 100 to 0, from a higher level to a lower level. Say a principal wants to talk with a student. Should he be able to telnet? Let's see. Ideally, yes, they should be able to telnet. So I can telnet either this device 2.2.2.2 or I can just ping the IP address 20.0.0.2, same thing. See, it asked for user access verification, means it was able to telnet. If I give 1 to 3, I am able to go to R2. I am able to connect to R2 from R1. From R1 to R2, possible. Okay, so I'll minimize this. Now, okay, let's not minimize that. Let's try from R1 to R3. So I'll give telnet. Okay, what was R3's address? 30.0.0.3. The DMZ 30.0.0.3. Okay. Something is not okay. It is in R2. Sorry, it is in R2 right now. Okay, from R1 I'm already connected to R2, so let me exit. So now I'm back to R1. Over here we can see R1. So now I would give telnet 30.0.0.3. It is asking for password, means I'm able to connect. See, I'm able to enter R3 router now. So that means from a higher security level, I can telnet to lower security levels, be it security level 50 or be it security level 0. Higher to lower is permitted by default. Okay, so I'll just exit this and I'll keep R1 minimized for now. Now let's come to R2. Okay, I'll go to R2. I'll just change settings and appearance over here. Now from R2, I will try to telnet 10.0.0.1. Okay, I'll try to telnet this particular router R1. It will just try. It won't be able to telnet. Why? Because I am trying to reach from security level 0 to 100. Not possible. Lower to higher, never possible. I will try to telnet from this 0 to this 30.0.0, 30.0.0.3. It won't. Because again, this is also security level 50. I cannot reach from 0 to 50. From 0, I can go down, but I cannot go up. So from R2, I cannot telnet to any, like either the DMZ or the R1. But now the tricky thing is this R3. This is in an intermediate level. So ideally, R3 should be able to telnet to R2. From higher to lower, 50 to 0, it should be able to telnet. But if it tries to telnet to R1, lower to higher, it should not be able to do. So let us see if that is the actual case. I'll go through this. I'll go to this R3. I'll click on change settings first, appearance. Make this font a bit bigger. Okay, now I am in R3. Now from R3, let us first try to telnet R1. So I will try to telnet 10.0.0.1. This is from lower to higher. It should not. Ideally, it should not. It is trying. Let's see if it succeeds. It won't succeed ideally. It did not succeed. Connection time mode. But if I ping from R3 to R2, sorry for this, yeah. From R3 to R2, that is from higher to lower, should it be able to ping? Yes, it should be able to ping. Let's see. Should we telnet? Yes, it should be able to telnet. Telnet. I want to telnet what? From R3, I want to telnet R2. That is 20.0.0.2. 20.0.0.2. See, it is accepting. If I give the password, I am able to enter R2. So this was how using an ASA, even if you do not pre-configure any particular access list or any particular specification or any particular requirement. Also, if you don't mention, some services are inspected by default, and this is the beauty of security role, security levels, we can say, because they do not permit the packets to enter, the inspected packets to enter from a lower security level to higher security level. Higher to lower, it's absolutely fine, but lower to higher, no, it's not. So we can just exit. So this was a brief demo on the default like ability to control the like access mechanism for telnet service. Now another very widely used service is ping service. Okay, so ping service by default, okay, if you see this command on ASA, okay, we can see that ping services are not inspected. And this beauty of ANS is that beauty of ASA is that if a service is not inspected by default, then it is going to deny that service. It is not going to let the ping service happen at all. Okay, so because see, we have set up the routing protocol and we can see that the telnet service is working. So ideally the ping should also work, but because it is not pre-configured or it is not inspected by default, ideally it should not. So let's see if we are able to ping something. So first I will go to R1, which over here we can see is at the highest security level. So from R1, let's try to ping R2. Okay, let's try to ping R2. R2 is 20.0.0.2. So I'll give ping 20.0.0.2. It is trying to send the ICMP packets. Okay, what is it trying to do? It is trying to send the ICMP packet. Can it send? Let's see. Ideally, it should not be able to send. See, success rate is 0. Even if it is at a higher security level and it is trying to connect to somebody at a lower security level, but because by default ping packets are not inspected, ICMP packet, ping basically means an ICMP packet, it is not inspected by default, hence it is not going to allow. Okay, so definitely it needs of no use trying to see if other combinations, because until and unless we do not enable ICMP service on this ICMP inspection, until and unless we do not enable the ICMP inspection on this ASA, nothing is going to, no ICMP packets are going to exchange between them, because there is no connection directly between the routers. Everything has to go through this ASA and everything will be inspected by this ASA. This is the beauty of ASA. Okay, so now how to configure this ICMP packets? So now there are multiple methods of doing that. So first method which I will go with is the traditional method of using access control list. So for that, let us first go and try to understand this. If we go to this presentation, we will see what do we basically mean when we say an access control list, an ACL over an ASA. So ACLs are used to restrict or to permit traffic, restrict or permit traffic when there is a need to have transmission initiated from a lower to higher security level interface. Okay, there is only one ACL or one interface in one particular direction or permission. Okay, so one interface will have only one ACL, no second thought about it. An ACL is used to permit or deny traffic from a source to a destination. You have a source, you have a destination. Now it's up to you whether you want to permit the traffic or deny the traffic and what type of traffic. Okay, when traffic is going from source to destination, it goes in and out of the Cisco ASA interfaces, as we saw, because there are no other connection. Whatever traffic has to flow from one particular source to another destination, it has to go through the ASA. And when it goes to the ASA, there are two terminologies that are being used: in and out. Something is going in, something is getting out. Okay, and when we configure this ACL, which you're going to see now, we would see how are we going to use this in and out commands so that like we can know what we want to configure exactly. So understanding the term in or out means is really of importance to work with ACL on Cisco ASA firewall appliance. In direction means the traffic is coming into an interface. So remember this, in means into an interface, out means traffic is leaving an interface. Okay, so if I want to configure an ACL for a traffic that is coming into something, I have to give the command in. And if I want to configure for traffic that is going out, I have to give out. And there is another keyword called any if I want both in and out, so I can use any. So I can either use the keyword permit or I can use the keyword deny. Okay, so this is what we will be seeing on how to do this thing now practically. So over here we saw this is the ASA and this is the configuration for ASA. So now how do I do this configuration? So over here, if we see these inspections are present inside what? Are present inside policy map. Okay, let's first understand the access control list. For how do we do that? I need to go to the conf. Okay, so I have to now give the access. Let's see, access. Okay, it's not coming over here. Exit. Access. So why is showing as enable mode? It's enable mode configuration terminal mode. Yes. Okay. Yes. In the config mode, we have this command ACCE access -list. So I will give access. Okay, there were two access. That is why it was not coming over here by default. Access list. Okay, I have to give a name for my access list. So I have to give the name for an access list. Let us give the name, say, I can give the name ICMP underscore permit. This is the name, ICMP underscore PERMIT. I have to permit the ICMP packets. Space. Now if I give question mark, I can see what can I do. I can either deny the traffic or I can permit the traffic. So let's try to permit the traffic. Okay, I will give the comment permit. And what I want to permit, access list. Okay, this is the name of the access list. ICMP underscore permit, this is the name. Access list is the keyword followed by the name access ICMP underscore permit, the name of this access list. I want to permit a packet. Which packet I want to permit? If I give the question mark, these are the different types of packets. Okay, so I want to permit the ICMP packet. So what would I give? Permit ICMP. Okay, permit ICMP from where to where? Okay, if I give question mark, it will tell me from where to where. Now I can specify a source IP address, or I can give any, or I can give an interface. I can do anything. Okay, so to keep the things short as we're running out of time, let's keep any. And again question mark, this is the destination, this was the source, from where to where. So from source any, destination any. Okay, let me give destination also as any. So now access list with the name ICMP underscore permit will, what will this ICMP underscore permit do? It will permit the ICMP packets from any interface to any interface. Okay, from any source to any destination you can tell. Okay, and now how do we activate this access list? The command is access -root space. We want to now activate this access list. What is the access list name? ICMP underscore PERMIT space. Now comes this in or out keyword. Now where do I want this access list to be implemented? Now if I, as we have limited time, if I implement it on the internal network or on the inside or outside network, it might get a confusion. So to demonstrate both the things, let's implement this on the DMZ network. Okay, because that is having a security level of 50, and then let's see how things go forward with that. Okay, so I'll implement this. I'll give the command in which interface I want to implement this on. Interface DMZ, enter. Okay, so now this is implemented on the DMZ interface. Now let us see how do the things, how does the ping command work and why. Okay, so now I'll go to the router R1. Okay, from R1, now ping traffic would come inside R3. From R1, I want to allow the ping packets, the ICMP packets to come inside R3. So if I give the same command ping 30 or not telnet, I want to ping. Okay, I want to ping. What is this? 30.0.0.3. 30.0.0.3. It is able. Why? Because we have given the access list, allowed the ICMP packets to enter into the DMZ. Okay, so that is why it is able to enter into the DMZ from R1, which is at security level 100. Now, if I try from R2, okay, R2 is not open. Let's no issues. Let's open R2 from here. Console, settings, change settings, appearance. Okay. Now, if I try to ping 30.0.0.3, okay, will it ping? Let's see if it is able to ping 30.0.0.3. Let's see if it is able to ping. Ideally, it should not be able to ping. Why? Because this is at a lower security level. Even if you have applied the traffic to come into this, still it is at a lower security level, so it should not allow. Okay, so see, we can see the success rate is 0. Okay, that is why. So if we are talking in, so if a traffic is coming inside this DMZ, okay, so traffic from a higher security level, ICMP packets can come from this one to this one, but not from this one to this one. Now let's try the reverse. Now I'll go to R3. Okay, now let's try the out one. Let's try to ping. Okay, let's try to ping R1 10.0.0.1. It will ping. No issues at all. Why? Because we have given any. So it will easily ping now because reverse is also happening. So from R3, we can definitely communicate with R1, but can we communicate with the lower security level? Let's see. Over here. Over here, I will go to in 20.0.0.2. 20.0.0.2. Let's see if it is able to. Ideally, it should not be able to. It is not able to. It is not able to. Why? Because this is at a, like, it was not configured for this one, right? That is why the success rate over here is 0%. So depending on our particular configuration only can this control which packets are flowing into the system and which packets are going out of the system. So to have the best understanding, we can just refer this R3. Over here, we can see that if you are trying, the ICMP packet was allowed, okay, and now if you are trying to like ping from R3 to R1, okay, so we are able to ping, but if you are trying to ping from R3 to R2, we are not able to ping. So this is how now we have allowed this ping command, so we are able to transmit from one router to destination. And we have to, like, if we are using ACL, the thing is that we have to configure for each and every specific interface the traffic which we want to allow and the traffic which we don't want to allow. Now this thing can get a bit tedious, a bit confusing. Okay, this thing might be a bit confusing and we might miss some terms. So there's another very simple trick of doing it. We will go to ACL. ASA, sorry. Now what I had given? I had given this command. So I'll just remove this command. Okay, so I will give no space. I will remove this access list for now. I'll remove this access list. Okay, copy this and give no. So no more access list is present over here. Okay, and if I just see from R3 I was able to ping R1, right? The success rate was 100%. Now if I again ping R1, it won't ping, right? Because I removed the access list. Now there is no access list, so no ping will work. From R1 to anything it won't able to ping. From R2 to anything you can't be able to ping. From R3 also you cannot ping to anywhere. No access list is there. So no ping packets are now allowed. No ICMP packets are now allowed. Now if we want, what we can do, a very intelligent thing to do, we can see that when we had this running configuration we showed, we had this, where is that one? Second over here, yeah. We had this inspect packets, okay, and these are present under this policy map, global policy and class inspection default. So if we add ICMP over here, okay, if we just add ICMP over here, the same way we were able to use the telnet service from a higher security level to lower security level, but we were not able to use the service from low to higher security level. All the same things, all the same complications can be easily applied using just one line of code. So we will just copy these two lines, just right click, copy. I went inside this class inspection default, and now what I have to give, I will just write the command inspect. See, these are different type of packets which we can inspect. And what do we need to inspect? We need to inspect ICMP over here. So inspect ICMP, enter. That's it, just one line, inspect ICMP, exit. Now see how simple the things are going to be. So from let's start from R1, the highest security level. Okay, from R1 ideally we should be able to ping anywhere. I'll try to ping DMZ, I'm able to ping. I'll try to ping outside network, I'm able to ping. From R1 I can ping to anywhere because it is a security level 100. I can ping to 50, I can ping to 100. No issues at all, without any other line of code. Okay, from R2, which is at the lowest security level, can it ping R1? Let's see if it can ping R1 10.0.0.1. It should not be able to ping. Why? Because it is at the lowest security level. So it's not able to ping the highest security level. You can see, verify that from here. It is not able to ping. Can it ping the intermediate DMZ now? No, it cannot ping even that as well. Why? Because still it is at a level of 0. This one is at a level 0. DMZ is at 50. How can it ping? 0 to 50 won't work. So now the tricky thing, R3. Okay, now R3 is in an intermediate level. We have not given any other line of code. From R3, I will try to ping higher security level. Can I ping now? Like we were able to do when we were using HCF, but now we'll just go with the logical flow. From lower security level, from say level 50 to 100, should we be able to ping? No, it won't let ping. But from lower security, like from 50 to 0, can we ping? Yes, we should be able to ping. And see, we are able to ping over here. Success rate is now 100%. So from 50 to 0, yes, we were able to ping. So this is how in ASA, we can configure the routing protocols, and we can configure the default inspection of packets, and we can configure the security levels. That is what we saw till now. How can we configure different security levels and routing protocols, and how can we inspect the packets? Either we can just give the default inspection policies for the packets, type of packets we want to inspect, or we can specifically mention the access control list, and we can configure the packets very specifically based on our requirement. So this is the beauty of ASA, using which, beauty of GNS3, using which we can simulate how the ASA works on our practical, on our real life organization, and how packets can be configured from we can control which packets we want from the inside to the outside, or from the DMZ to the inside, and how the packet should flow, and the different policies we can check. So I hope this video was informative, and thank you very much for your time.